Hello, this is Dr. Oz. Today I would like to talk about another integer linear programming problem, which is called market share optimization, which is an important area in marketing. So in this example, I have 8 consumers. I could have hundreds of them, of course, and I'm trying to maximize my market share, which I don't have any. And this, based on my survey, the first consumer currently values whatever he or she consumes right now in terms of pizza 52 points. Again, this could be out of 100, right? So it all depends on your scale, and you can normalize your values. And for example, if I want to get the business of consumer number 5 or consumer number 5 type, it could be type of the customer, which can reflect thousands of people in my population, currently values his or her pizza at 58 points level. So if I beat this 58, I can get this business. And this consumer type is valuing thin crust 2 points and thick crust 8 points, mozzarella 6 points, blend 11 points, smooth 30 points, chunky 20 points, and so on. So, and I need to pick one of these crust types, either thin or thick. I need to choose one of these cheese types, mozzarella or blend. I need to choose one of the sauce type, chunky or smooth. I need to choose one of these sausages, mild, medium, or hot, so that I can maximize my market share. All right, first thing first, like always, I would like to start my model with the objective. So objective could be maximization problem or minimization problem, and this is a maximize market share problem. And I would like to use green cell here. Excuse me. And the second question is, what are my decision variables in this problem? Decision variables. So I have obviously these many decision variables, which are 9 different types of decision variables. Control C, Control V, and these are binary decisions. So should I pick those or not? I like to use yellow color for my decision variables, and I call them 0. These are binary, right? So 0 for not picking that attribute, 1 for choosing that type. So binary decision variable. All right. And the third component of the prescriptive analytics model is my subject to, which is constraints, rules and regulations in this problem. Okay, so I have 8 different types of consumers. Control C, right? These 8 types. Control V. And actually I could just label them a little bit differently so it's more clear. Consumer number 1, consumer number 2, 3, 4, 5, 6, 8. All right, perfect. And if I would like to get the business of this consumer, I need to basically beat the competitor. So constraints have left-hand side values versus right-hand side values. All right, so let's start with the right-hand side values. So right-hand side value is here really, if I want to beat this competitor, basically I need to get at least 52 plus 1 points. So I would put 52 plus 1. If I get 53 points, basically, I will beat the competitor and get the business here. So I can drag it down. And my left-hand side values have to be greater than or equal to these values so that I beat my competitors. And my left-hand side values are going to be some product of coefficients times variables, since this is a linear program, always integer linear, but it's still linear constraints and linear objective function. The coefficients for the first consumer are given right here, comma, I would like to multiply those values with their corresponding decision variables. So this number has to be greater than 52 or greater than or equal to 53. All right, I would like to drag this one down. To be able to do that, I need to lock my red cells, which my decision variables. I highlight the red area right here, press F4, enter. Now I can drag it down. So what happened? So if I choose 1, 1, 1, 1, basically I cannot get the business of the first consumer because my competitor offers 52. I need to get at least 53, so I could only get 46. However, I could get the business of no one, actually, because all the left-hand side value sounds like smaller than no one likes thin, mozzarella, smooth, and mild. All right, let's don't make it mild then. Let's try medium. All right, can I beat anyone? Let's see. Oh, I still cannot beat. Oh, I can get one customer. Okay, so this is better than going mild, I guess. Okay, so these are my constraints so far. I like to use some reddish color. However, the point here is that I don't need to beat them all, right? In this case, I'm forcing my constraints to be beating all my consumers. So that's not my goal in this case. This is not the target in this company. It could be, but in this case, not. Market share optimization is not. Basically, I need to pick and choose my type of consumers or markets to penetrate. So what I'm gonna do is I'm gonna define another set of constraints, and I will label them this way: consumers. Or let me just copy these settings here, titles, Control C, and I will put them right over here. Okay, so now I will give my model more flexibility by defining these 8 decision variables. What are those? Binary decision variables to choose my consumer type. So I don't need to get all of the business. I can get, let's say, only 1 and 3 if I want to get it. So now I need to update my right hand side values because now I will make my model easier to solve because I don't have to satisfy everyone right now. So I will multiply those values by corresponding binary decision whether I should get that consumer or not. So if it's 0, basically, I don't need to worry about that consumer type, okay? So now what I can do is I can drag it down this formula. Okay, perfect. And as you see now, I don't need to satisfy consumer 2 because 0. Again, I put these numbers just for now randomly. I'm gonna delete them, or you can keep them. Excel solver will calculate those yellow values for me. Go back to my objective calculation. So I'm trying to maximize my market share. Basically, I'm trying to maximize the sum of the consumers that I obtain. So I would like to column sum of this area. Currently, based on this model, is 2. Can I beat that? I have 4 other constraints regarding to my attributes. So what are those? Obviously, in this problem, I have to pick either thin or thick. So I cannot choose both. I cannot choose none. So, or mozzarella or blend, or mild, medium, or hot. So summing of these attributes should be equal to 1. All right. So what I'm gonna do is I will put here 1 for crust, 1 for cheese type, 1 for sauce type, and 1 for sausage type. So these are all right hand side values. 1, I need to pick exactly one of those. Since I say exactly, these are equality constraints. My left hand side values are, in this case, crust types thin or thick, this plus this. Cheese type mozzarella plus blend. Sauce type smooth plus chunky. And finally, sausage type mild plus medium plus hot. One of those has to be chosen. All right, so these are 4 additional constraints that I have. I have one more constraint actually. Actually 2 more sets of constraints, which means that I have decision variables, all these yellow values and these values should be binary. All right, I'm all set. Now I can communicate this model with Excel Solver. First thing first, file. If you don't have Solver under data, you need to edit by file, options, add-ins, analysis toolpack add-in, go, and then click OK. And now it may take a few minutes, and then you should have under data tab solver add-in. Click on that. First thing first, objective is the green cell. Click on that. This is a maximization problem. Choose your decision variables. I press Control, highlight these decision variables, and also highlight these ones. I didn't release my control button. Now I have 2 sets of decision variables. Let's add my constraints. Add. First, these values have to be greater than or equal to these values right there. Perfect. Add. And these values must be equal to these values. Click add. And these values must be binary. Click add. And finally, these values must be binary. Click OK. Again, I put random numbers here. You can keep it blank or whatever you want to do, but Excel will calculate those for those yellow values for me anyway. I want to make sure that my numbers are not negative. I want to make sure that I'm using linear program because this is still a linear program, although I have binary values because my objective is linear function and my constraints are linear functions. Click solve. Perfect, you got optimal solution. Click OK. So the best solution here you can get is 50% market share. 8 different types of consumers, you can capture 50% of them, which is 4. By creating a pizza that is thin crust, bland cheese, chunky sauce, and make sure that it is mild. And if you do that, you can get the business of consumer type 1, 2, 6, and 7, and that will maximize your market share. Again, this is another application of integer linear programming, and I hope you enjoy this video. Until next video, enjoy business analytics.